Now in this video, we'll see the DMVPN phase 2 implementation by using OSPF protocol. Now we're going to use OSPF like in the previous video we have seen RIP. Now we'll try to understand if you're using OSPF over DMVPN phase 2, what are the necessary changes or the configurations we need to add. Now the first thing we need to ensure that your phase 2 configuration is okay. Now in my scenario, the phase 2 is correctly configured. Let me check. I think I didn't remove the configurations in the previous topic, so I'll simply remove that one. So in the previous topic I used RIP protocol, so I'm going to remove that protocol on all the routers. So let me just add this command, remove RIP on all the 3 routers before I get into the OSPF configurations. On the router 2, router 3, as well as on the router 4. Now once we remove the RIP configurations, we got the DMVPN phase 2 properly configured between router 4 to router 1. You can see all the 3 different DMVPN tunnels are established. Now we got a phase 2 is correctly configured between all the routers. That's something we need to check first. So the phase 2 configurations. So that's the first requirement. Now the second thing is we need to ensure that the particular DMVPN tunnels should allow multicast traffic. Now in order to allow the multicast traffic, we need to configure some command like IP NHRP map, multicast commands. Either we can use the dynamic option or we can use manual configurations. Like in my scenario, these are the commands you can see. These are the summary of the commands, and these commands are already configured on my routers. I did these commands in the EHRP configuration, so I didn't remove it. It's already present. So I have a configuration on the router 1. Let's go and verify. On the router 1, show run interface tunnel 1, 2, 3, 4. Now on the router 1, you can see the NHRP map commands, which allows you to send the multicast addresses for selected spokes. Now the same thing on the router 2, router 3 and router 4, we got a similar commands configured allowing the multicast for 15.001, that is hub. Now that's the next thing we need to ensure this. This is something really mandatory whether it is a phase 1 or phase 2 implementations, and these mappings are not really required if you are using static NHRP configurations. Now in my scenario, I'm using dynamic NHRP, so we need to add these mappings to allow the multicast traffic. Now the next thing is we need to configure OSPF. So next thing we'll try to configure OSPF area 0 on all the routers. Now I should see the neighborship because I think it allows the multicast address, so probably we should see the neighborship. Let's verify by doing some configuration here. Now I'm going to advertise the 10 network with a /24 subnet mask, and then also advertising 192.168 1 network, which is in my LAN. That's it. No need of router ID because anyway it will automatically take the router ID. So on the router 2 as well, I'm going to configure the same commands, but the only difference is I'll change the LAN interface. On the router 3 as well, now you can see the neighborship is up. On the router 1, let's try to advertise 3 network here. I can see the neighborship is up, but there should be some problem like we had in the phase 1 4 network. Now if I go and verify on the router 1, you can see the continuous console messages coming up, the adjacency is going down and coming up. Now this is the default behavior. Now the main reason is because of the network type mismatch, because whenever you configure any tunnel configuration, it can be a multi-point tunnel or multi-point GRE tunnel or a normal tunnel, it is going to treat this particular network as a point-to-point. Now if you want, you can verify by using show IP OSPF interface tunnel commands. Let's say show IP OSPF now show IP OSPF interface tunnel 1, 2, 3, 4. Now you can see the interface network type is point-to-point here, because even though you configure the tunnel, the default is point-to-point. Now that is something what we don't want here, because if it is a point-to-point, then there is some issue here because we are not using point-to-point connections. Now we need to change the network type here. Now we need to change the network either to point to multi-point, or we need to change the network to a broadcast network. Now probably if you're using phase 2 implementations, I generally go with the broadcast implementations. But again, if you're changing the network to broadcast, ensure that your router 1 should be the DR and the remaining routers should be other routers, more similar to your familiar implementations. And that is something what I'm going to do here as well. So I'm going to change the network to point here. So whenever you configure OSPF, because there is no split horizon rule issues here, that is something what you will see in the distance vector protocols. Now here we don't have those kind of issues. Now what we need to do, we need to change the network type. I'm going to change the network type to broadcast network. And next thing what I'm going to do is I'm going to ensure that the router 1 should be the DR and all the remaining routers should be other routers. So to make that possible, what I'm going to do is I'm going to change the priority value on the router 2, router 3 and router 4 to 0 so that they should never become a DR. Because the default election is based on the priority value. If there is a tie in the priority value, then it is going to see the router ID. So I'm going to router 4. The first thing, I'll change the network type on all the routers. So interface tunnel 1, 2, 3, 4. And I'm going to say IP OSPF network broadcast. And I'm not going to change the priority value on the router 1 because default is 1. And I'm going to make it on 0 on the remaining routers. IP OSPF priority value 0. So let us configure the same thing on all the remaining routers. On the router 3 as well as on the router 4. Now once we change the network type, now we should see the neighborship should become stable. That's what I'm expecting here. Show IP OSPF neighbor. I can see the neighborship is going. So the neighborship is in Xstart stage. Now you can see the neighborship is full. So show IP OSPF neighbor, you can see the neighborship is full. Now the router 2 and router 3 and router 4 are the DR other routers. And the same thing I should see on the remaining routers as well. I can see the router 2 is forming the neighborship here. Now there's no neighborship between router 2 and router 4 because the reason is if you verify the mapping information here. Now we just have a multicast mapping only with router 1. And if you want a neighborship between all the routers, then we need to say IP NHRP map multicast. We need to say 35.003 and then we need to say 45.004. Now this is something you have to do in case if you want a full mesh neighborship. And the same thing we need to configure on the router 3. 1, 2, 3, 4. Anyway, I have configured for the local router. That's something not required. We can simply say 25.002. The same thing I'm going to configure the same thing on the router 4 as well. On the router 4, 4 to 3 and 4 to 2. I can see the neighborship is coming up slowly. You can see the neighborship is two-way stage between other and other. And now if I verify the routing table, I should see the routes coming into my routing table. Show IP route OSPF, you can see 1 dot, 2 dot and 3 dot network coming into your routing table. Now whenever you are using OSPF in case of phase 2 implementations, ensure that you are allowing the multicast traffic on that particular tunnel interfaces. It can be a phase 1 or phase 2 implementations, especially if you're using dynamic NHRP mappings. And configure the OSPF, and we need to change the network type either to point or point to multi-point. Now in case of broadcast networks, ensure that your hub router should be the DR. So because the default route exchange happens through hub, it will not happen directly initially for the first time. So you need to ensure that your hub router should be the DR and all the remaining routers should be DR others.